Welcome to Smith Weekly Discussions, an occasional program for our members of Smith Weekly Research. Please note this program is a private discussion and everything contained herein is for entertainment and educational purposes only. With that, we hope you're in a comfortable position along with your favorite beverage to enjoy the discussion. We remind our audience to examine our show notes attached to each of our shows to better understand how our program functions. Before we get into our discussion, we want to say thanks for questions coming from our audience at Smith Weekly, including Matt S., John D., Mark R., and Andy S. We have a returning guest on the program today, and one we're pleased to have come back to talk with us. Professor Ian Plimer is on the show, back with us. Ian is Australia's best-known geologist and emeritus professor of earth sciences at the University of Melbourne, where he was professor and head of earth sciences from 1991 to 2005. He is currently a director of various Hancock prospecting companies, a private group. He previously served as professor of head of geology at the University of Newcastle from 1985 to 1991, professor of mining geology at the University of Adelaide from 2006 to 2012, and research professor of ore deposits at Ludwig Maximilians, Munich, 1991. He also held positions at the University of New England, the University of New South Wales, and Macquarie University. Ian has published over 140 scientific papers and co-edited the 5-volume Encyclopedia of Geology. And we want to credit this bio to Connor Court Publishing, where we pulled it from. Ian's most recent work as author is presently the title of Skeptical Always, which is just published, as well as recent titles, The Little Green Book, a series for kids, teenagers, and adults on the topics of energy, climate change, CO2, and life basics. Ian is also the author of Green Murder, a complete masterpiece of 500 plus pages on energy and climate. You can find his books via multiple outlets, as well as direct from the publisher, Connor Court Publishing, their website, connorcourtpublishing.com.au. Professor, welcome back to the podcast.
Well, thank you for having me here again. That introduction means I've got nothing to talk about now.
Yeah, Ian, absolutely. That was a long one, but I thought this time I would change it a little bit from last time. Yeah, so many things that you've done in the past and so many things you're doing presently. It's hard to keep up, to be honest. And you're a fleet of forces here working all together in concert. So I don't know how you get so much done and how you travel so much. It's quite impressive at your age and full tilt, full time, and you need more runway to keep on doing what you're doing. So
For me, there's only two speeds, flat out and faster.
well, we better get going because I know you have a flight to catch here soon and moving on to more work important topics. So appreciate you coming on and spending a little bit of time with us in the audience. Well, why don't we kick it off here, Ian? Your opening comments, I suppose, we'll start with that on where we stand on the narrative of climate change. At least that is the main title that's still being used out there, or climate control, as I'll rebrand it here. Not the air conditioning climate control, cooler temperatures. Rather, that's an incidental, but using climate to further control you in the sense of climate control. How are you seeing this evolve at this point, Ian? Are the wheels coming off? Is it gathering steam? Your thoughts?
In the Western world, the wheels are wobbling. They're wobbling in Germany, they're wobbling in the UK, other parts of Europe, they're wobbling in Australia. But in the US, it's changed significantly due to President Trump. And I think the reason why COP30 in Brazil was a monumental failure, or flop 30, was due to President Trump. I think he's basically been a realist and said, look, this is a load of nonsense. We are not going to send our country bankrupt because of some ideological ideas that people are pushing hard. And I think there's significant change coming. And the change is actually resulting not from the science and not from common sense, but from the hip pocket. It's starting to hurt. Some countries are now finding their unemployment's going up, their GDP is going down, their productivity is going down, and this is all related to the cost of energy. So I think the world is changing, but you have to remember that you're fighting an ideology, and that data doesn't win against an ideology. The second thing is this is the new religion. This is replacing Christianity, which is on the decline in the West. And the third thing is that there are a whole host of new businesses that have been opened up as a result of this climate change hysteria, which is turned into, as you quite correctly said, control and control of everything you eat, everything you do, whether you travel, where you travel to, how you travel. And there are a lot of people who are making a lot of money out of frightening us to death. And they're not going to give up this source of income easily. So there is a change happening, but to actually reverse the process, it's going to be a long, hard road yet to hoe.
Lots of battles to go for sure. This war on CO2, it's still here, still moving. All the things you said, absolutely correct. Certainly on some platforms out there will be censored, other platforms will be fine here. And it's funny, you say the wrong words and automatically it triggers and you can't do this, you can't do that, or it's suppressed, which all the more means that the more important word of mouth is. Word of mouth is definitely important here as we continue to discuss these issues and just sit here and scratch our head over some of the stupidity that we see out there. So I really appreciate the opening comments there, Ian.
You use the words, you can't say this or you can't say that. My answer to that is I do say it. And I do say it because I live in a free society. I live in a democracy. And if people are trying to stop me saying things, then this is an attack on my freedom. This is an attack on the democratic systems. And so I think when you said climate control, you went right to the heart of it. This is what it's about. It's a new mechanism of controlling every aspect of people's lives, not controlling the aspect of the elite lives. And the elite use a huge amount of energy per capita. They're quite happy to fly to another part of the world in their private jets and pontificate about the evils of emitting plant food into the atmosphere. So I think we just have to use the language to say, no, I'm not going to accept you using words that make it look as if I'm an evil person. I'm going to use my freedoms and say exactly what I think. And if you don't like it, take a teaspoon of cement and just harden up a bit.
I like that. That one's a good one. One of the key messages here is the audience listens in from whatever platform you are on. That in itself causes the question. Is the conversation not allowed and you shouldn't be talking? That right there is the starting point to say something is absolutely wrong with the narrative. Then I would encourage the audience to go take a look. As soon as there's a problem with you shouldn't be saying those things, automatically that raises the question of further investigation as to the narrative perpetrator. So I
Exactly.
would,
And by what right does one say to someone else, no, you don't have the right to say this? And who are you to say this? By what authority do you have? I will say what I think. And if you don't like what I think, it's bad luck. So, for various elites, especially bureaucrats who are unelected, to tell me what I can say and what I can't say and what I can think, I don't accept that. And one's only got to look back into the past and see when such situations arose, and these were totalitarian environments. So just don't accept someone telling you what to say or think.
that right there is a perfect starter for folks to do some further work here. Folks that are listening in that have started to believe this narrative or have started to believe that this narrative is correct, this right in itself is enough to start questioning that and doing further investigation. And I think the further investigation, you don't have to go too far below the surface to figure out that there's some serious problems with the narrative. So I always encourage folks to take a look at that.
I'm going to pull you up on this. You used the word believe. Now, believe is a word that's used in religion and politics. It is not used in science. So if someone says, do you believe in climate change? You know, immediately you're dealing with someone with a prolapsed IQ. These people are not very smart. Of course, climate change occurs. We geologists have been seeing it for thousands of millions of years. And to use the word belief is telling you that it's actually a religion. It is the new religion. It is a religion that's replacing Christianity. It is a religion where you pay penance, where you pay indulgences, where you have holy books, where you have great priests like Al Gore. And like many religions, people haven't read the Holy Book. Who out of our listeners has read the IPCC reports? It's nearly 4,000 pages long, the latest one. Who's read that? Now, if you read that through the eyes of a scientist, you will come to a very, very obvious conclusion. No one has shown that human emissions drive global warming. It hasn't been shown. So you have to use the word belief because there's no evidence out there. So, as a scientist, I just attack the foundations, and the foundations, as soon as you ask the questions, you find that there's nothing there. Now, if there were scientific papers that demonstrated that human emissions drive global warming, you would never hear the end of it. They would be shouted from the mountaintops. And I always ask people pushing the other side, just give me half a dozen scientific papers that unequivocally demonstrate that human emissions drive global warming. It's never been done. So we're starting with a fallacy right from the beginning. And on top of that, we've built a house of cards. And on top of that, we're creating a whole lot of opportunities for people to make money. And there's absolutely nothing wrong with making money and making enormous amounts of money, but it's based on something that's false. So if we can demonstrate it's false and it disappears and you lose money, well, that's just bad luck. You took a risk and you failed.
Appreciate you bringing that forward and laying that out as you did. Very well said, Ian. I want to go back to a few key fundamental questions for the audience, maybe who hasn't taken the time to do their own work, which is probably a lot of the public. They maybe have relied upon a headline narrative, or maybe not, or maybe just the audience who's taken the narrative hook, line, and sinker, to use a fishing analogy. Is it correct that much higher levels of CO2 have occurred in the past? Give us an idea of that in terms of magnitude, and then compare that to today's levels. Essentially, I would say that today's levels are probably par for the course, to use a golf analogy, in the context of climate cycles over multi-decades or multi-hundreds of years timescale. Just talk a little bit about that, Ian.
Well, I'll just talk about the present. We can live in an atmosphere with a very high carbon dioxide content. Currently, the atmosphere has 0.04% carbon dioxide. Now, we breathe in 0.04%, and we breathe out, because we metabolize carbon-based foods, we breathe out 4%. So it's 100 times more. So what's going on? Well, if you really, really, really passionately believe in net zero, then the only solution is to stop breathing, is to drop dead. So we can live with quite a high amount of carbon dioxide. We know that from submarines. We know that many horticulturalists will pump hot carbon dioxide into the glasshouse, and this is done for a very good reason. The optimum level of carbon dioxide in air for plant growth is about 3 or 4 times the current level. So horticulturists will burn propane gas. That'll produce water vapor and carbon dioxide, which goes into the hot exhaust fumes go into the glasshouse, and bingo, you can get much better yields. In the geological past, we've had carbon dioxide go up and down. It went down at periods of time when we've had a lot of vegetation form. This vegetation ended up forming the great coals, such as those in Pennsylvania in the US, and in the southern hemisphere we have coals which are just slightly younger. These coals tend to be lower ash. These coals tend to be lower sulfur. They form in a slightly different environment to the northern hemisphere coals. But we've had the atmospheric carbon dioxide go up and down due to plants. Over the last 500 million years, over the period of time when we've had multicellular life on Earth, the carbon dioxide content has decreased from 0.7% to 0.04%. This means that we are drawing down carbon dioxide into limestone, into vegetation, which ends up as coal, into animal matter for floating single-celled organisms, which ends up as oil and gas. We have been drawing down this carbon dioxide. Now, if we keep doing this, and if we halve the amount of carbon dioxide in the atmosphere, then plants will struggle to survive. And the founder of Greenpeace, Dr. Patrick Moore, argues that we have a duty to feed our plants. Now, of course, he's a plant ecologist, and he'd say that, wouldn't he? But we have a duty to feed plants, and the way to do it is to burn fossil fuels, to burn oil, to burn coal, to make cement, because without that, then plants are not going to live. If we go even further back in time to about 700 million years ago, we had about 20% carbon dioxide in the atmosphere. We know this because we have the rock dolomite, and some of you might use dolomite on your gardens. And dolomite is a calcium magnesium carbonate. It's very easy to make in the laboratory, and to make it, we have seawater and an atmosphere of carbon dioxide above it, and we just warm that seawater and we precipitate dolomite. Now, we see kilometers thick of dolomite lying on top of debris left behind by ice some 700 million years ago. This means that we were withdrawing a huge amount of carbon dioxide out of the atmosphere. So we can measure the volume of the dolomite. We know the chemical reaction to precipitate dolomite, and we can back calculate and say, well, the atmosphere had at least 10% and perhaps even 20% carbon dioxide in it. And what did we have? We had the biggest ice age that this planet has ever seen. We had ice at the equator and at sea level, and it was global. And it didn't happen once, it happened a number of times. So if we look back in time, we can see that carbon dioxide is just a normal planetary gas. This normal planetary gas varies a lot, but for a very long period of time, we have been drawing down carbon dioxide from the atmosphere. Our first atmosphere was rich in hydrogen and helium, which have escaped into space. Our second atmosphere was rich in carbon dioxide, and that's been drawn down into limestones and coals and oils and carbon-rich sediments. And our third atmosphere, the one we currently live in, is rich in oxygen. And if we end up with no carbon dioxide in the atmosphere, or very little carbon dioxide in the atmosphere, we won't be producing oxygen. And we'll go to our fourth atmosphere in the planet, and that will be an atmosphere which is dominated by nitrogen with very little carbon dioxide and oxygen in it. And that's not an atmosphere conducive for life. So just as we've had an evolution of rocks, an evolution of the oceans, an evolution of life, we've also had an evolution of the atmosphere. And that's telling us that carbon dioxide is not fixed. And if you're to believe the story, the catastrophist story, that this trace gas, which we emit as humans by having normal human activity, if you're to believe this story, then you have to believe in a static planet. Now, this static planet is a view that has been around for hundreds of years. It's been absolutely totally dismissed. And again, we geologists dismiss that, the same as we can dismiss the fact that carbon dioxide is not at the one static level in the atmosphere. It goes up and down a lot, but over the long period of time, it's been going down.
Good stuff. On the testing methods, I want to ask you a little bit about this. When you go back and you test, when you interpret the data and you back test, back calculate this information, obviously there's some groups out there that take the data. If they don't like it, they manipulate it. That happens, of course, to fit the narrative. Just talk a little bit about, if you were taking measurements today to determine levels in the past, just talk about a couple of those methods that you think are very sound methods and how you would go about it, just for the uninitiated in the audience.
Well, the uninitiated would never have heard what I said, because we have a very selective use of information by the mainstream media, and the past is never looked at. History is never looked at. Archaeology is never looked at. Geology is never looked at. Why? Because it gives a different narrative to the story that we're being sold, and that story is to frighten us witless. Open your wallets and pay up, and you might actually be saved. Now, if you are not a scientist, then you can go to history. And if we go to history, we can see that we've had warming and cooling periods. The planet has cooled down since the time of Jesus. It was about 4 or 5 degrees warmer then. And then in the time of the Vikings, it was much colder. The planet has warmed up since then. Then we had medieval times, and it was a warming period. It was so warm that in Europe, we could have 3 crops a year. We had a huge excess of wealth. This money was used to build cathedrals, to build universities, to build monasteries. That medieval warming was 4 or 5 degrees warmer than now. We know that in medieval times, wheat and barley were grown on Greenland. We know in medieval times that cattle and sheep were grazed in Greenland. You can't do that today. We know that in medieval times you could dig a grave for a body in medieval Greenland. You can't today, it's permafrost. So the planet was much warmer in medieval times, much warmer than now, and it's cooled down. And it cooled down then into the Little Ice Age. And of course, what's going to happen after a Little Ice Age? Well, it's going to warm up. And we came out of that Little Ice Age in 1850, and we had 3 periods of warming and 3 periods of cooling. So if carbon dioxide drives warming, and after 1850, we were certainly in the Industrial Revolution, if carbon dioxide drives warming, how come we had 3 periods of warming and also 3 periods of cooling? So there's no relationship between carbon dioxide and warming. So history shows us that. In archaeological times, we can see that we have had great periods of warming and cooling, and we had our current interglacial started about 14,500 years ago. This was a period of time when we were a little bit closer to the sun, where we warmed up a little bit, and the ice sheets started to break up. The ice sheets, especially in the Northern Hemisphere, especially in Canada, dropped into the Atlantic Ocean. We had temperature inversion, and we had 2 very cold periods. The best known one is called the Younger Dryas, and in the Younger Dryas, temperature cooled very, very quickly. We humans huddled into villages. That's when we invented villages. Things must have been tough because we had fortified villages. We invented animal husbandry. Instead of going out hunting, we got docile animals and kept them in pens. Instead of going out looking for grass seeds, we actually grew these. So we invented agriculture. This was a great period of time. And we came out of this period of time, the Younger Dryas, and we warmed about 15 degrees in 10 years. Now that's global warming. That's very well recorded on ice cores. It's very well recorded in archaeology. We warmed up, then we cooled down again when we had about a 500-year period of cooling, again due to armadas of ice that broke off from the ice sheets and filled the oceans, and we cooled down a bit. Then we warmed up, and we had maximum warmth on planet Earth in this current interglacial between about 8,000 and 4,000 years ago. And actually, we've been cooling down for the last 4,000 years. And we can see a lot of evidence in cliffs where you've got a nick at the bottom of the cliffs telling us that sea level was about 2 meters higher than now. So in archaeological time, we see that temperature's gone up and temperature's gone down. These changes have been very, very rapid. And these changes, these warmings, have been unrelated to human activity because we had no industry on planet Earth then. And then when we go into geological time, which I mentioned before, we see carbon dioxide levels go up and down enormously, but the general trend is downwards. We see that temperatures have been up and down. We've had a number of major ice ages. These ice ages have been global. Within these ice ages, we've had glaciation where the ice has expanded. Within these ice ages, we've had interglacials where the ice has contracted. Now, ice is a very rare rock on planet Earth. We get ice that's been on Earth for less than 20% of time, but we've got ice now, and we're currently in an ice age. And this ice age started 34 million years ago, and we have periods of glaciation when the ice sheets expand and periods of glaciation when the ice sheets contract. Now, this is not driven by carbon dioxide. It's driven by the position of the continents. It's driven by factors which you never hear about. For example, there are 150 geothermal areas and volcanoes beneath the West Antarctic ice sheet. Why don't we hear about those? They have clearly driven changes in climate. The position of the continents has driven climate change, and so much so that we can see cycles of climate. And we have cycles of climate every 400 million years, and this is based on where the continents are and how they're pulling apart and stitching back together again. We've got cycles of climate every 143 million years, and that is whether we have a bad galactic address or not. We have cycles of climate every 100,000, 40,000 and 20,000 years. And this depends upon the orbit of the Earth. Every 100,000 years, the Earth's orbit goes from elliptical to circular. Every 40,000 years, we have the axis of the Earth change a little bit. And every 20,000 years, we wobble a little bit like a top. We also have cycles based on the sun, and the sun puts out variable amounts of energy. We've just come out of a grand solar maximum. We're heading towards a grand solar minimum, but we've known for more than 300 years that we have 22-year cycles of the sun, and we also have 88-year, 217-year, 1,500-year, and 10,000-year cycles of the sun. We know that we've got cycles of the moon. And every 18.6 years, we push warm water up into the Arctic. Just look at history. You can see that multiples of these cycles, especially the 60-year cycle, is when the Northwest Passage is open. So look at history. Look at when the Northwest Passage has had ships go through it, wooden ships go through it, and it's on a 60-year cycle. And this 60-year cycle was an oceanic cycle, was so prominent that the Chinese actually constructed their calendar based on a 60-year cycle. And this was based on crops, but that clearly was dependent upon warm water and rainfalls. More recently, another cycle has been found, and I'm a bit skeptical about this until I see more data, but that cycle is a 2.4 million year cycle based on Mars. So we have cyclical events of climate, which we've known about for a very long period of time. And we also have accidental events of climate. If you have an asteroid hit us and fill the atmosphere with dust, or if you have a dirty big volcano and fill the atmosphere with dust, that changes climate. We also have the unseen, and the unseen is our volcanoes beneath the ocean, sitting on the ocean floor. We've got nearly 70,000 kilometres of mid-ocean ridges. This is where we're pulling apart the planet. We have thousands of active volcanoes and hot springs along those mid-ocean ridges. Off ridges, we have 3.5 million modern and ancient volcanoes. Every time this type of volcanic rock comes onto the sea floor, it exchanges heat into the ocean floor, into the ocean floor waters, into currents. Now, that basalt, which comes out on the sea floor, can have up to 13.5% carbon dioxide dissolved in it. That basalt comes out at 1200 degrees Celsius, and it cools to the seafloor temperature at the bottom, which is 2 degrees Celsius. That heat's got to go somewhere. So for every 1 cubic kilometre of basalt that comes onto the sea floor, that gives us enough energy for 30 massive hurricanes. We never hear about that. There is a very strong correlation between El Nino events and swarms of earthquakes on the mid-ocean ridges. These swarms of earthquakes are telling you that molten rock is rising and pushing apart other rocks. These swarms of earthquakes are telling us that there is an eruption coming. Now, we have this wonderful correlation between earthquake swarms and El Nino events, yet we never hear about it. You only hear about this from volcanologists. So what we hear in the media about climate is a very, very filtered story of those people who are constructing models, these garbage in, garbage out models. These models are those where there's a selective amount of information used. These models assume that carbon dioxide emitted by humans drive temperature. And of the 102 models that have been published over the last 50 years, not one of them has got it right. Not one of them has predicted what has actually been measured. So the models don't work, but we are being told about the future from models which we know don't work. We've been able to check these models by some of the assumptions the models make. The models concluded that there was going to be a hotspot above the equator, about 10 kilometres up. You can check that with satellite measurements and with balloons. No such hotspot exists. So the models are wrong. And everything we are being frightened about is based on models. It's not being based on data. And looking at what happens in the past and looking at cycles which come around time and time and time again. So climate change is very complicated. We know from the past that we've had massive and rapid climate changes, and we know from the past that previous climate changes have never, ever, ever been driven by carbon dioxide. Now, that's the answer. God knows what your question was.
Yeah, thank you for that. Good stuff. Suffice to say, there's a lot of unanswered questions out there. You could suggest that it's a get rich quick scheme in the sense of the narrative. There's no doubt about that. I mean, you can easily apply the money side of things to this and come to some pretty fast determinations. And then lastly, it's just not as simple as going down to Antarctica, coring ice for 1,000 meters, even saying, oh, we've got a problem. You can see how this can be heavily manipulated, and there's a lot of stuff we just don't understand.
Well, coring the ice has given a problem. If you core the ice and you can measure volcanic dust in the ice, you can work out when those eruptions took place. Then you have basically a chronology of when the ice formed. And then as snow falls, it traps a little bit of air in it. This then consolidates to ice, and you have trapped bubbles of air. And you can measure what the chemistry of the air in the past was. And this has been done. And from various chemical fingerprints in the ice, you can work out what the temperature was. So when we first had these ice cores, there were plots done showing temperature against carbon dioxide. It was almost a perfect correlation. And it showed cycles of temperature change, and these were clearly related to the orbit. But on more detailed sampling, unfortunately, a different story arose. Rather than there being a perfect correlation between carbon dioxide and temperature, it was shown that every time you get a natural temperature increase, something like 600 to 1600 years later, you had an increase in atmospheric carbon dioxide. So, what that's telling us, and we never hear about this, is that it is temperature that drives carbon dioxide in the atmosphere. If you warm up the oceans, you will release carbon dioxide. It's temperature that's driving the carbon dioxide content. It's not carbon dioxide driving the temperature. So this we know from chemistry. We've known it from Henry's law for a very long period of time. Now, you can do this test. It's very easy to sit down with a cold soft drink, not my choice. A cold beer or a cold champagne might be my choice. And then you commit a cardinal sin. You sit there and you don't drink it. You just watch it warming up. And as it's warming up, it keeps bubbling. So you are releasing carbon dioxide in that champagne, beer, or soft drink from solution as that solution warms up. That's exactly what happens in the Earth's oceans, and that's exactly what's recorded in Antarctic ice on a very, very fine scale. So the ice core drilling was used to show that we're all going to fry and die and the carbon dioxide's driving everything. And that was the first pass of scientific work. And that's normally what you do in science. You do a quick first pass to get an idea of what's going on. And when the more detailed work was going, the exact opposite was shown. So I find it quite exciting that you can come to a scientific conclusion. And when you get more data or better data, you actually have to change that conclusion. Now, what's happened with our climate catastrophists is that they haven't changed their conclusions based on the data. And this is why I argue it's not science. In fact, I would argue it's the biggest scientific con that we've ever seen in the history of the planet.
Yeah, it's bad news, and we've seen these cons in other industries as well. Most recently, as as you and I well know and have experienced, among other things. With that, I was going to discuss this temperature correlation, and you just covered that quite well. So we'll bypass that. And in fact, CO2 levels do not have a direct and definitive correlation to higher temperatures at all. And so that's good to confirm here. And when it comes to terminology, Ian, I think that this title of climate change, if you want to call it a title, at least how it's spun, that it sounds like it's a new recent phenomenon, which in fact is misleading. It's not. Climate and its change has always existed and has changed over various time frames, as you just alluded to. And the bigger picture of that change is really the climate cycles, which is the longer, great periods of time that we really as humans can't comprehend. Is that about right? Would it really be better titled if you had to? Climate cycles.
Or I think just dynamic Earth is probably the best way to describe it. And we've known about climate change for a long period of time. And early geologists who called themselves natural philosophers 200 years ago were arguing about great big boulders that were strewn across Europe. And one theory was, and this came from the Norwegians, that this was due to a great battle between the trolls, and these were the boulders that they were throwing at each other. Another interpretation came from William Buckland in the UK, and Buckland argued that this was the remnants of the flood, the Great Flood, Noah's flood. And these huge boulders were left behind by turbulent waters during the flood. The third interpretation came from the Swiss, who actually looked at the toe of glaciers and looked at glaciers retreating and saw that great big boulders were left behind. And they concluded that Europe was once covered with ice. As it transpired, it was later shown that the UK was once covered by ice, as was Ireland. Then later work showed that parts of North America were covered by ice, and on we go. So the conclusions changed when more evidence was available, but there had been a huge discussion in the scientific literature 200 years ago about ice ages and whether there were layers of ice on top of Europe. Years ago, they didn't know how long ago, we now know. There were huge discussions about how this ice appeared and how it disappeared. Now, the Europeans were quite used to ice. They see it in many places, and they'd seen glaciers expanding and retreating, and they knew of many villages in the Alps of Switzerland and Austria that had been covered in ice, and then the ice retreated, and then the ice expanded again, and then the ice retreated. In other parts of the world, such as in South Africa and in Australia, some of the geologists saw the same sort of material, but in ancient rocks, and said, well, wait a minute, in Europe, you might have very recently been covered by ice, but we had ice covering parts of the southern hemisphere a very, very long time ago. And this was poo-pooed. The German scientist Alfred Wegener, who was a Greenland explorer, he was a meteorologist, he spent a lot of time looking at ice, and he looked at the way ice deformed, the ice pulled apart and cracked, how ice formed ridges when it pushed together. And then he looked at the shape of continents and started to think, well, I wonder if these continents were joined together and that they'd been pulled apart. And when he floated that idea to the German Geological Society, he was absolutely pilloried. Firstly, because he was a meteorologist, and secondly, because he was an up-and-coming young meteorologist, and this was just not in accord with the ideas of the Swiss. But he did more work and got more evidence and showed that you have debris left behind by retreating ice in South America, and that joins up perfectly with material in Africa. You've got material which are identical chemistry, volcanic rocks in South America joined up to Africa. And on he went, looking at comparisons across continents. He then started to look at fossils. He found fossils in Greenland and became quite interested in them, and was able to show that we had the identical fossils in one sequence of rocks on the edge of one continent, and they appear on the edge of a continent right across an ocean. And he put together the idea of continental drift. He was poo-pooed, and he published that idea in 1912, and it wasn't until the mid-60s that we had new data and new thinking, and people said, well, yes, this idea is valid. But that was done by looking at ancient climates across continents. So we geologists have been arguing about climate and climate change for hundreds of years. And we just yawn when someone talks about climate change and tries to tell us it's something new. We know that planet Earth is dynamic. Every time you get an earthquake, every time you get a volcano, every time you get a landslide, every time you get a hurricane, we know that this is planet Earth being its normal dynamic self. What would worry us is if the planet didn't change. And what we are being told is the planet is static, and that the changes that we observe and measure are due to human activity rather than due to natural processes. So, again, if you ignore a very, very large body of science, and that is the earth sciences, you can come up with a conclusion that's totally incommensurate with the data. And that's what's happened with the ideas on climate change, which initially started as global warming. And when warming couldn't be shown, then it was changed to climate change. And so every ripple in the ocean, every hurricane, every subsidence of the land, every change in temperature was due to climate change. And the fact that we might have to change these temperature measurements on the land to demonstrate climate change is a turpitude, but it's been going on for a long period of time. So um, we have to remember planet Earth is dynamic, and you have to be able to separate what processes might be driven by humans and what processes might be natural. Now, the energy required to change a climate and the forces required to do this are absolutely enormous. Humans do change the surface of the planet. We can see that with land clearing. We can see it at Mount Kilimanjaro with land clearing. We've had less precipitation of rain to give us snow on Mount Kilimanjaro. We see that humans have got a massive amount of plastics that have entered the oceans from the 8 major rivers, but these are from third world countries. Oh no, we don't criticise the third world. We only breastbeat and criticise the first world countries. So humans certainly are changing the surface of the planet, but we're not changing major processes such as climate. There's just too much energy involved to do that.
Well said, Ian. Thank you for that. Certainly a lot of mismanagement out there as well that's helped contributed here, significant piles of mismanagement. So appreciate you bringing up those couple of comments that spurred that thought. Why don't we shift gears here? I know you've got some limited time here, and I don't want to take up too much more of your time for this episode, but I want to shift gears over to academia for a moment. You've been in so many different related industries, private, public, government institutions, private institutions, all these things mixed. Take us back a few years, and by that I mean it's could be a few decades, Ian. But when you were active in academia, you still are, but when you were more active back then in some of these institutions, when did you start seeing the shift away from simply going through the scientific process properly, interpreting the data without a bias or a prepaid outcome, to a more narrative converted driven process, I suppose? Because I think to some degree your experience put you around and in this transition period at some point during your career. Any thoughts on that?
Yes, I've been in the academic world since the 1960s, and I was one of the fortunate ones that went to university by winning a bursary. The only way I could go to university, because we came from fairly modest circumstances, the only way I could go was to win a bursary. And in those days, there were very few universities. Very few people that finished up school went to university. There were about 2% of school leavers went to university. And then there was a great filter a couple of years before that of people who didn't even get to the final couple of years of school. So from those children that started in kindergarten, they're probably only less than 0.5% ever finished up and went to university. Universities were places of scholarship, and the bureaucracies of various governments would employ people that came from universities, especially those who had the classics, who had studied a language, who'd studied English literature. And these were people who could demonstrate that they could think, and therefore they were employed by the bureaucrats, by the civil service. There were the more practical people, such as in medicine and veterinary science and dentistry and engineering and in science. And they had skills which, with good mentoring and further growth, could end up actually adding value to society. Now, university then was quite a privilege. There were very few people who went, and those who went were the elite. They were the ones who were the elite intellectually, and those were the ones who um, didn't necessarily come from a rich household. If you won a bursary, it was not means tested. Today, if you want to go to university, you have to have a pulse. You have to be able to show that you're pumping blood in your veins. And you can do a course in gender studies, you can do a course in politics, a course in philosophy, and you end up being totally unemployable, probably even unemployable as a barista. So my view is that in today's world, we have far too many students at university, far too many universities, far too many universities who are attracting as many students as possible because their budget is based on the number of bums on seats. And if you get a lot of people, you have a bigger income. And so university, I think, has been totally contaminated by mediocrity. The staff now are those people who are people who I would have taught. These are people who have experienced a system which has been dumbed down to the point where universities once might have had a class of 3 or 4 people at the senior level, and that was regarded as successful because these people were specialists. Now you couldn't have a class of 3 or 4 people because that would be regarded as uneconomic. And universities are totally and absolutely about how much money the university can bring in from student fees. Now, what happens in this country, and I think it's in many other countries, is that students go to university, do a degree in left-footed Morris dancing, end up with a huge debt, and suddenly realise they don't have a job. I was recently talking to a lady who got the university medal, which meant she was the top person in the university with her degree. She got an honours degree, and what she studied was freshwater ecology. Now, there are about 3 jobs in Australia in freshwater ecology. That's it. So she followed her passion. She was probably seduced into it by her lecturers and was totally and absolutely unable to get a job. Her solution was, oh, well, I'll go and do a PhD. And my answer to her was, well, you just end up more highly qualified, but still unable to get a job. So we're getting, I think, far too many people at too many universities doing too many useless degrees. Universities were originally constructed during that wonderful period of time when we had a lot of money, and that was in the medieval warming, when we produced so much extra money from multiple crops every harvest, every year, that we built universities, we built monasteries, and we built cathedrals. And we built universities for a very good reason. And this was to train young men for the priesthood. It wasn't women, it was men. They were not engineers, they were not scientists, they were people who had a knowledge of the language and of the classics. And it wasn't until the 19th century, when we had an industrial revolution, that we needed engineers. We needed people who understood the science which is behind the engineers. We'd already started to produce people in medicine. A bit later, we had people in veterinary science and dentistry. So universities started as places of scholarship for the church, then ended up as places of vocation, and that's the university system I went through. And now we have various countries aiming to have 60 or 80% of their people with university degrees. Well, so what? This means that the standards have gone down. This means that the people are being seduced into doing a degree in a subject that's totally useless, and they can never get a job, and they end up with debt. So I think we've abused young people terribly with our education system. The second point is that our education system is meant to create people who can think for themselves. The universities have become places of activism, and many university staff now are proudly activists, and they promote their activism rather than promoting knowledge. And so they produce an army of activists who eventually hit reality, and that reality is that they cannot get a job. So we have, again, the letting down of young people going to university and being fed activism rather than being trained to be skilled in some subject and to be able to think. You have to be able to think because we're constantly facing problems. and you need thinking skills to solve those problems. So I think we've had this dumbing down of our education system over the last 50 years. We now are suffering for it. We do have the occasional private university that is established that has gone to counteract this, and mainly by emphasizing Western civilization and Christianity and the role of history, but they're few and far between. So I am very sad that our young generation has been lost. They've been lost by being corrupted by an activist system that is taking their time. Now, governments like this because governments keep young people off the streets for a few more. This solves unemployment problems. You can have people aspiring to get a degree, but there are only a certain number of jobs in human movement that you can get, and then that's it. There's only a certain number of jobs that you can get in gender studies, and that's it. And in both of them, you can count them on a sawmiller's hand. There are just very, very few jobs. So the governments have deliberately kept young people off the streets by raising their hopes and not having them unemployed at an early age. And it's been a very cynical exercise by governments and especially bureaucrats who are unelected and basically tell governments what to do. It's been a very cynical exercise of our young people where we've destroyed their future. And it's no wonder that we have drug problems. It's no wonder these people are rebellious. It's no wonder these people will not accept knowledge.
You point out a lot of issues. I appreciate you saying that, Ian, and pointing out some of these issues that persist there. Most definitely it is. And there are some exceptions, as you pointed out, but in general, just as again, a generalization here, most of these are a wealth transfer vehicle and you come out worse off. That's the issue I think that is here. And as you said, and it's not a coincidence with some of these goals, the quality have gone completely down the drain. And I think with that, Ian, really just boils down to what you said a little bit there. You alluded to the dumbing down, with AI and everything else happening there. I think it makes the point to raise the question, why should anybody think for themselves anymore when you've got AI, right? And furthermore, why don't we lose a few more jobs by giving that up to the robots? So basically, these universities are robot academies. And why should we think for ourselves when we're taught like robots and we have AI?
Well, AI concerns me a little bit. I have done various experiments on AI on subjects that I know very well, subjects where I'd be regarded as an expert. And I get an AI interpretation of it. And in many cases, it's demonstrably wrong. So within AI, there is also a bias, an ideological bias. So if you try to get information from AI, you're certainly not getting knowledge, you're getting information. And AI has its uses, but it's not the repository of knowledge. So unless you've been trained to question everything, and unless you've done your own experiments and measurements and observations and failed, then you won't question anything. You have to actually have the experience at failing. AI gives you the perfect answer every time. So again, I fear what the next generation is facing unless they've had drummed into them that they have to be skeptical of everything, that they have to be a critical thinker, that they have to know the difference between information and knowledge. They have to be able to see something that's ideologically tainted to something that's repeatable and validated. So the young person now faces a lot of problems with AI, and they don't have the tools in their arsenal to be able to say, no, this is nonsense.
And I do think this is another mechanism for more control,
Oh, yes, of course, yes.
without a doubt. And so just those outcomes alone outstrip any positive benefit from them, Ian. Period. You can't cut it another way.
The genie's out of the bottle. Once the genie's out of the bottle, you can't put it back in. So we have to live with AI. We are being told it's the greatest thing since sliced bread, but I heard the same. I heard the same when the internet came on. I heard the same in this country, in Australia. We first got television for the Olympics in 1956. I heard that this was going to be the great educator. It isn't. It brings people down to the lowest common denominator, and on we go. So these wonderful new methods are good to be able to use, but you have to be able to use them critically.
That's right. People still have the ability to still make that choice for now. So definitely make the proper choice. Well, Ian, why don't we move on here? Got a few other things to talk about, then I'm going to let you go. Just wrapping up, kind of tied to the comment I made earlier, the question I had for you earlier. Do you think there is this prevailing tendency for folks who are on, say, the back end of their careers, the ones who've seen enough to know knowledge exists for them, those folks that were successful enough that they no longer needed that paycheck from the institution that they worked at, to be more open, honest, and more willing to take strong, well backed positions on the subject matters that they had a lifelong experience and knowledge of? Obviously, we know there's some people that continue to stick with maybe the so-called narrative or what they were told to do. But do you see that that's the case, Ian? As you look back over your career, is there more of this? You might be an exception, Ian, actually, because I think you've told it as it is your entire career. But do you think some folks, as they get on the back end of their career and they have that detachment, they're independent, they're well off to where they could say more of the straight talk, the facts?
Well, in my career, I've always been a square peg in a round hole. I've always called it as it is. Much of that derives from my background. Much of it derives from the fact that the first serious jobs I had were working underground in mines. That's when you're with reality. That's when you're dealing with safety all day, every day. That's when you're dealing with having to make a profit, having to be productive. And that's when you're dealing with miners who are very good observers, who will call it as it is, and they just don't care. And I learned a lot from that. And all my life, I've been a troublemaker. And so this latest book, Skeptical Always, is a collection of 50 essays. The first one was written in 1971, and the last one was written earlier this year. And these essays are basically showing my skepticism over a 50-year period, my skepticism of everything, and my skepticism of that's derived from lived experience and the fact that I'm a scientist and I should be skeptical all the time. And just a little bit of a diversion. There's some stories in there which are meant to entertain. For example, I have a story about a wake that I went to. It was a fabulous wake. It was my own, that had been organised in an outback village. I had one story about how, when I was working in Iran in 1977, I was kidnapped by the Mujahideen, and I wasn't aware what they wanted from me, but it took a while, and then under gunpoint, I was ordered to give them a geological opinion on this little outcrop of copper ore or that outcrop of chromium ore. So that was an interesting formative period of my life. Another one where really made up my mind about dealing with people who might be in control of your life and who are not very well balanced. And this is a description of being a passenger in a corporate jet. We ran out of fuel at 31,000 feet. We crashed into forest land, and I survived. And this was criminal negligence on the part of a pilot. But that, of course, frames your mind that if you're dealing with people who are negligent or who are bureaucrats who may well be exceeding their powers, then you have to stand up and fight them. Another little story, an entertaining one, was where I looked at creation and I looked at God creating the heavens and the earth. And on the very first creative move by God, he got served with an injunction from Greenpeace. And I just went through today's environmental laws and how, if you wanted to have the biblical creation, it would not be possible under today's environmental laws. And that was just a little bit of humour. A number of articles on climate change, a number of articles on children that I've met in Turkey and other parts of the world. Kids are a great window into the way society works. So this book, Skeptical Always, is a book of the evolution of my skepticism over time. But I've always been skeptical. I've always been challenging authority. I've always been one who says, well, no, wait a minute, show me the evidence. I'm happy to entertain the idea, but let's see the evidence. And if I put up contrary evidence and it's dismissed, then I know I'm dealing with someone who's a charlatan. Now, the modern university is that staff have to toe the line. And I learnt this when I served on the Australian Research Council. Concurrently, I was working on the German Research Council and the Swedish Research Council. And in the Australian Research Council, we were given orders from the government that there was a war on cancer. And if anyone was seeking research monies that might help to cure cancer, then we had to fund them. So if you put in a research grant that ingrown toenails and cancer have a relationship, and if you can work on ingrown toenails, then we have to fund you. And this has also happened with climate change. I was then not with the Research Council, but we now have people who are funded because they've used the word climate change in the research grant application. Almost every university has an institute of climate change or an institute for predicting future weather. This is par for the course everywhere across the university. Now, most of these people are mathematicians who create models, who try to tell us using someone else's data what is going to happen in the future. Now, there's a long track record of people predicting the future and failing. We are funding people that are eminently unemployable, who are being funded by taxpayers to pursue their hobby. And I'm not so sure that we should have these people in universities. Meteorology is a valid area to deal with, and I had a department of meteorology when I was head of earth sciences at University of Melbourne. And in fact, the university wanted to kill off the Department of Meteorology because they were not producing too many graduates and they were fairly expensive to run. And I said, no, it's a valid discipline. Ironically, the same people in that meteorology department now criticise me because suddenly they've become experts in climate. So universities survive off government grants. They survive off the taxpayer. And if the government funds studies in gender, then there will be staff to consume that money. If the government funds studies on climate change, there will be climate change institutes appear everywhere. And my view is that a lot of these people in these institutes are eminently unemployable. They've got themselves a job, and when they retire, they realise what a waste it was, and they speak up. If they'd had any courage, and if they'd been true scientists, they would have spoken up from day one, saying, look, I'm a little bit concerned about this. It doesn't fit in with the geological data. Let's explore it a little bit further. But that hasn't happened. So why have we got that? Well, we produce too many graduates in fields which are probably not very useful. And that's because we've had too many people in universities. And that goes back to my original point about having universities as elite places of scholarship rather than places where if you have a pulse, you go and you can end up as one of the 80% in society with a degree, but you might be unemployable. So I think people change their mind when they've retired simply because they've realised they've probably wasted their life and they probably haven't been honest with themselves. I find it's much, much better to tell the truth because if you tell the truth, you certainly don't have to remember what you said. So this book, Skeptical Always, is a book showing the evolution of my thinking into the current position that I'm at now. It's taken not very long to get into this position. That position was probably 40 years ago that I was skeptical of everything, and I think being skeptical is a very honourable characteristic, but it's regarded as negative. People who are called skeptics, it's used as a pejorative word. I see it's a very positive word. So people who later, when they retire and speak the truth, I think are saying, look, I haven't been truthful all my life and I've been a product of this dumbed down system. It's about time that I could sleep straight in bed. And that's rather sad, I think.
Ian, a great perspective on that. And that is the cold, hard truth of it all right there, is that exact issue. So I appreciate you going through that. And I also further appreciate you tying that into your book. And absolutely, Skeptical, always great title, by the way, and certainly folks should be skeptical. You have to understand the interests that are tied behind all this and how the money works that is behind the scene and all the things that you started to come in to talk about here, as well as just today and the things that we've covered. You have to be able to question those things, and to question those things and actually put in the work, you have some of those traits of being skeptical always. Really just ties in with the title of the book and everything else that you started to bring up there. On the book, what is the best way for folks to go obtain a copy?
In the US, from Amazon, or probably the easiest way is direct from the publisher, connellcourtpublishing.com.au, Connell, Connor, Connell Court Publishing. And I'm very proud to have Connell Court as my publisher. I've had 9 books with Connell Court. It's a husband and wife business, and I keep the husband and wife and 4 children alive. Every book I write, and I normally have a book a year, every book I write is a good seller. Some of them are bestsellers. And I'm very pleased to say that I keep a family alive. And I keep a family alive by having a publisher that is bold enough to publish my ideas. This is a minor publisher. They're not a major group like Random House, and I've published with Random House before. They are just a small publishing company, but they publish a lot of obscure books of scholarship, many books on religion, and I'm the one that keeps the cash register moving. So I've become very good friends with the publisher and his wife and the 4 girls, his 4 daughters. I get on very well with them. I see them a lot. I'm always having to buy birthday presents for the girls. And it's turned out to be a wonderful relationship. So support small business, support the publisher, Connell Court.
Ian, well, you've kept the lights on for a lot more people than just them, but congratulations on that. And also all the books you have published with them as well. I think definitely if folks have the capability of buying directly, that does improve putting the profits in the right place compared to Amazon. So very much encourage people to take a look. I'll be getting a copy. Matter of fact, it is on the way. It'll take a little while coming from Australia, but it's on the way to me, which is fantastic. And encourage people to take a look at a number of your titles. Very good, useful information and knowledge coming from that. Ian, thank you. And then also with that, what are you doing right now, Ian? Talk a little bit about some of the things you're up to. Are you taking any new mining clients, energy clients? And then finally, any public speaking events that you want to mention?
Well, the reason why I'm snorting and coughing and blowing my nose is I've been in aeroplanes a little bit too much. Now, I'm very proud of my carbon footprint because at my age, I have developed a girth where I can't hug a tree, but I can certainly feed them with carbon dioxide, and that's what I'm doing. So a couple of weeks ago, I was in South Korea for a few days. I went to the Pohang Steelworks of POSCO, very interesting in Korea. They have about 40% of their power comes from gas, about 30% from nuclear, and about 30% from coal. They intend to get rid of coal to generate electricity. So all I can say is best of luck. The Pohang Steelworks were built, I think, in 1938. And they're not as energy efficient as a modern steel plant would be. They certainly are using traditional methods of making steel, and that is strong coking coal that holds up a column in the blast furnace, limestone, which comes from Korea, and iron ore, which comes from Australia. The coking coal comes from Australia, and they produce all sorts of steels. But they're under a lot of government pressure because of their so-called emissions of plant food, and this is going to create a little bit of stress for them. After that, I was in Brisbane, which is the state capital of Queensland, and I was looking at some of the coal seam gas projects to the west of Brisbane, about 400 kilometres west of Brisbane. And these, in terms of gas, are quite significant. Eastern Australia produces a lot of gas. It's mainly coal seam gas. We export a lot of gas from 2 export hubs, and the rest of the gas goes into pipelines into Queensland, into New South Wales, and into Victoria. But the irony is that Australia has an energy shortage, yet we have over 2 million years of uranium in the ground. We have tens of thousands of years of coal in the ground and thousands of years of gas in the ground, yet we have an energy shortage, and we have high energy costs. And this is due to government inability to control bureaucrats who are basically unelected and driving a green agenda. So I was in the gas fields of Queensland. Then after the week after that, which was week before last, I was in Broken Hill, which is a mining town to the west of Sydney. To the far west, it's about 1,300 kilometres west. The ore body at Broken Hill was discovered in September 1883. It is the biggest accumulation of lead, zinc and silver in the world. It's produced hundreds of millions of tonnes of lead, zinc, silver ore. That one mineral deposit led to the industrialisation of Australia. I've been working at Broken Hill off and on, and I've lived there for a while. Since the 1960s, I've found 2 ore bodies at Broken Hill, so I very proudly can say I've created hundreds of jobs for decades, and I'm very pleased as a geologist to create jobs. I'm probably regarded as the expert on these sort of mineral deposits in the world, so I go there with great regularity. I still have a house there. I've still got a lot of friends there, and the city of Broken Hill, the city council wants to honour me on Australia Day, which is the 26th of January, wants to honour me as the Citizen of the Year. Well, I think if you find a few ore bodies and create hundreds of jobs for decades, maybe you've been a reasonable citizen. And as a result of all of my scientific work on the Broken Hill ore body, there was a new mineral found there by some scientists some 15 years ago, and they named it after me. And I'm very proud to announce that this mineral is totally and absolutely insoluble in alcohol. So they got it right. Last week, I was in Saudi, and Saudi Arabia has some very ancient rocks. There are some known lead, zinc, silver, and gold deposits in these ancient rocks. But Saudi has initially been a country where their revenue came from religious tourism and then came from oil. And now they're thinking in the future. They're thinking, well, we have the right rocks for producing minerals. We want to actually start to produce minerals. And so they're having a big push to get international groups to come into Saudi to do mineral exploration. And I'm part of a group that's doing that with Saudi partners. So one family group in Australia are linked with a Saudi family. And this was a trip to spend time with the Minister for Mines, with the family, and with some of our staff there. I came back 5 days ago, is it? And tomorrow I go to Istanbul in Turkey. That's for some experimental, fairly novel experimental cancer treatment. And then I go on to a minerals conference in London, and I'll be doing another podcast there. That's a podcast with Constantine Kissin. And then after that, I come back to Australia via Montreal to go and see my son and his wife and my 3 grandchildren, and come back to Australia. Then I think before Christmas, I've got a day in Melbourne, a day in Perth, a couple more days in Broken Hill. And then I've sworn on the Bible that I'm going to be at home for 3 weeks over Christmas and New Year. And I go back to Saudi on the 11th of January, again to go out in the bush and have a look at, or out in the sand dunes and have a look at some rocks. A good time of year to go. It's a bit windy, it's a bit cool, but it's not 48 degrees Celsius. And there's also a conference associated with that. And I don't know whether I'm coming back from Saudi or whether I'll come back through the US. So that's the sort of schedule I live. I turn 80 next year. I think that's a pretty rapid schedule for someone my age. I do an enormous amount of driving. in Australia, sometimes I just can't get the right flight, so we'll drive. So going to and from Broken Hill, that's only 350 miles, and I basically go by car. Um, and it's a pleasant drive. I get phone calls done. I can listen to some good classical music. I go to and from Melbourne quite a bit. And that's about 550 miles, and that I do to get medical treatment for cancer in Melbourne. So I'm constantly on the go. My unfortunate wife has had this sort of life for 50 years. She's got her own interests, but it's starting to get a bit hard now because her health is not as good as it should be. Mine is, with this cancer, is a bit of a battle. And so one day I'm going to slow up this travel, but it's very, very hard to do with the amount of commitments that I've made. Now, somewhere during this, I'm able to write books. Somewhere during this, I write articles for magazines. I've cut back my public speaking a little bit, and this is because of security reasons that I'm now being told that because of various events that have happened worldwide, that I should have fewer public talks that are widely advertised. And if I do have them, then I have security. And the security that I have, these are ex-SAS soldiers or equivalent to the US Special Forces. These are people who don't take prisoners. And so I have specialist security now, which I think is absolute turpitude. Why should I have security? Because I'm out there espousing different ideas based on data. But that's the world we live in, and this has arisen because of the Charlie Kirk assassination. And it's unfortunate. That's the way the world's got to be. I live a very anonymous life. It's very hard to find me. And with my travel schedule, it's really only my wife and one other person that knows my travel schedule. So I'm an extraordinarily busy person, and I find things like this podcast are actually relaxing because I'm not on the treadmill, and I use long flights for thinking time and also sleeping. And I have to hit the ground running wherever I go. So I need to sleep when I travel. But I'm finding that books like this, Skeptical, always have arisen from this sort of travel over 50 years. And these are 50 essays. They're short essays, no longer than, well, some are longer, but they're mostly about 1,200 words. Now, you can read one of these essays and just get a bit sleepy when you've finished it, put the book down and go to sleep. You needn't start at page one and finish at the last page. You can start at any story. They're not continuous. They're all stories that are meant to capture people's interests. And most of these stories I've written when I've been mid-air. So I don't waste time. I'm going to be dead for a very, very long period of time. And I make sure that every minute that I'm on this planet, I can be contributing, working, or expressing ideas.
Ian, just fantastic across the board. Thank you so much for sharing some of your travel schedule. First off, my hat's off to the wife. Certainly, she's had to put up with you all these years. Must be she must be very happy. Contrary to what you what you said there with your travel schedule, we didn't talk so much about Australian energy or global energy. We'll have to save that for another episode. Mismanagement, of course, on that front. And then your plate is completely full, I would suspect at this point, but I'm sure for some important people, certainly you would be there to assist. And probably on a future episode, we need to talk on geology as a subject and talk about mineral deposits only for the purposes of the episode. And my best wishes to you in your travels. Take it easy out
Thank
there.
you.
Very sad to hear about the fact that you need additional support, so to speak, on the security front. But nonetheless, good to have that in place for now. And then also, finally, take it easy on the cancer. Continue with your alternative work on that front. Very good to hear by many respects in the generalist cancer community as far as the things that you should be doing. You've extended the runway so far compared to where you should have been at this point. So
Well,
congratulations.
I should be dead. I should be dead. If I'd taken chemotherapy, I would have been dead. I did an enormous amount of reading on this. Any new drug that my medicos want to give me, I say, well, fine, give me the scientific literature on it and we'll talk about it tomorrow. And I'm a voracious reader. I don't understand a lot of the medical literature, but I certainly understand the scientific method and the statistics of the number of patients that were dealt with. So I have a little bit of a personal interest in how long I live. I suspect that if I play my cards right, I'm going to die with cancer rather than from cancer. But we will see.
Absolutely. Well, keep up the efforts there, my friend. Definitely very important to do. Well, Ian, look, I would ask how folks can reach you, but I would suggest at this point that they contact an intermediary to reach you. And of course, there's lots of ways you can get a hold of Ian. You can certainly talk to us to hook up if needed. And I'll leave it at that before we go. How do you think best folks can get involved by word of mouth to their friends and families about some of the issues out there? Maybe climate as an example. Anything you want to say on that front?
Well, if you start talking about climate at a dinner party, you will start to lose friends. I have, but that's the price you pay for speaking the truth. I find that talking to the average worker is a very, very good way of doing it. The average worker is very skeptical. They're sick of being the bunny where every single government move, they end up paying more tax. And so just keep talking. Make sure you know your stuff. But if you don't, there's another way of doing it. And that's to ask questions. So if someone claims, oh, this is global warming, all you do is you say, show me. And then you'll say, oh, that's interesting. What is the scientific reference on this that I can read? And immediately you've got them snookered. Immediately they have no answer. So do what any skeptical person does. Just ask questions. Show me. Show me the evidence. That's all you have to do.
Absolutely. Well, perfect. Really appreciate that one. Always good to get your comments on that and how folks can get involved. We always encourage that. Ian, well, I'll tell you what, took enough of your time. I'm going to let you go. Always a pleasure to talk with you. Keep up the work, and we're hoping you'll come back to speak again with us soon.
We will. Thank you.